All right. Now I have made some notes for today. Let's see if I can get to them on my OneDrive. No, my OneDrive. Yeah, here's some notes. Ooh, nope, it's the wrong one. This one. Oh, I should do that, I guess. All right, so I turn. No, I got to leave it on. All right, so today I just wanted to review all the normal forms with you, and we know from the textbook pretty well what first, second, third, and Bcnf are. And so why don't I just go over those a little bit. I also think I'm going. Okay, when I'm done with this Word document, I'll upload it to the class because I'm probably going to make some changes to it. But if we look at the quizzes, let's just look at the quiz for today, and we can go over what these normal forms a little bit. Oh, right. Was this? Okay, let me. What did this look like? That was just what I created out of this. Let's see. We used this in something, right? We used this in a. This was an assignment. Oh yeah, that's right. This was your assignment. And okay, so this is actually a pretty good one to look at. As you know, first, for something to be in first normal form, the rules of every attribute has to be named. You can't have any unnamed attributes. So in other words, you can't have any unnamed columns. There can't be any duplicate rows. There can only be, or there has to be exactly one value in every cell, if you want to think of it that way, or every field has to be occupied with something. There can't be any holes. So now technically, what I've given you here for that assignment, I think this is what I gave you, or maybe this is what you have. Yeah, I think this is what I gave you. This is not even in first normal form because technically there are holes here. It doesn't. This guy George Smith, this field over here is supposed to be the project. Is supposed to have to do with the project that one of the projects that George Smith is working on. And George is not working on any projects. So those fields are not even really valid for this record unless you accept nulls or nothings. And why is this in here? Why it's in here because we need to store information about George Smith someplace, and we only have one place to store it. It's our nice table here. And so George Smith ends up going in this table only once. Heather and Tom are in there more than once because they're working on more than one project. But if you're working on one project, you'll be in here once. And if you're working on no projects, you'll be in here once. So so technically, this is not even in first normal form. So to put it in first normal form, we have to probably split it right here, we take this right here, and so I'm going to mess with this. Okay, I'm going to turn off autosave and mess with this, and I would like split this into two tables right here, and I got it, and then make this into a relation. Take out these empty ones, and if there's any doubles, more than one in here per project, which there may be, there's two 1100s and so on. You can go like this. You can delete this, shift the cells up, and then you can select this, and you can remove duplicates. Boom. Oh, there's no duplicates? 1100? Oh. Oh, that's because the employee hour. Oh, that's because it's different employee hours. Oops, I made a mistake. These need to be attached. Never mind. These should have been attached to the employees. This is a relation. So this can be data, remove duplicates, and you end up with with just a list of projects. This is now in this is in first normal form. And so is this is not. Let's take. I'm trying to figure out some. Okay, let's do department EID. Oh yeah, department EID budget and office. This is a tough example for this example, but it would be department and EID. Okay, so yeah, this would be the primary key because it's department and employee, and this is see. Let me take if I take the department out of here, I just end up with employee. All right, so this is not a good example here either, but because we've got sales here. Let's just take sales out of here for the moment. Okay, so this here is in first normal form. It turns out that this is blank because because James does not have a phone. Okay, so here we are representing the absence of a phone with a blank. So it's not null. Null means we don't know if there's a phone or not. We may not have the information, or the information just does not apply. And in the case when you're joining tables, you may end up with null attributes in the result, depending on the way you join it. But anyway, in this company, this guy's an IT guy, and he's just down on phone numbers, or I guess, or something. He just uses email, so that's fine. So this is in first normal form. Okay, it passes first normal form, but it does not pass second normal form because in second normal form, do I have this in this notes? Second normal form, all key attributes, all non-key attributes are functionally dependent on the whole key and not just part of the key. So we're just looking at non-key attributes, and we're looking at what they are dependent on, either directly or indirectly. And so we have here we have these are the key attributes. So we can I can make this bigger. So these are the key attributes. Let me make them yellow or something. And these are all the non-key attributes. So we look at every non-key attribute and we see what determines it. And we see that the first name is determined by only EID. The last name is determined only by EID. The phone is only determined by EID. The email is only determined by EID. The budget is determined by department, and office is determined by department. So there's not even anything that's dependent on both of them. So this is a terrible example of this is absolutely not in second normal form. And to make them in second normal form, we are just going to split this into two tables. We would just split this into two tables. We need this in one table. No, we need this because we need to know that EID is a member of this department. So EID is a member of that department. So one table has all of this. No, this. This is one table. I'm going to copy this and maybe put it, I don't know, put it over here. Put it over here. Okay, so that is one table, but EID is the key. So I'm going to take this and maybe put it over here. So this now is not in this case. All of the non-key attributes depend only on the key. This depends only on the key. This depends only on, okay, but this is not in first normal form because there's duplicate keys. So let's take the duplicates out. Data, remove duplicates, and we end up with just this. Okay, now this is in first normal form because there's no duplicates. It's in second normal form because every non-key attribute depends completely on the key. In fact, any table in first normal form that only has a single attribute as a key is automatically in second normal form. It's only when a table's got a composite key do we have to even worry about whether it's in second normal form. And if second normal form, and you determine that it's not in second normal form, if there's some non-key attribute that only depends on part of the key. So, yeah. All right. So now this is in first. Now this is in first normal form. It's in second normal form. We haven't checked for third normal form yet. Let's go back to this. We can get rid of all this, and this now would be a. Let's get rid of the duplicates. Okay, so this is now the key. Get rid of the duplicates. I like this. Data, remove duplicates, and we end up with just this thing. And so this now is it's in first normal, it's in second normal. So you recall in a table such that may have your name, your names and addresses, if the zip code and the city are attributes in that table, or the zip code and the city and the state are attributes in that table, that table is not in third normal form because, as we know, the city and the state depend on the zip code. the zip code determines the city and the state. You can go to USPS.com and you can put in the zip code and it'll tell you the city and state. So that's an example of something that's that could be in second normal form but not in third normal form. Turns out that that all of these are also in third normal form. It looks like. Let's see. Is there any relationship between those two? I don't think so. Probably not. But we assume no. Is there anything between? See, this is the key, and so is there any relations, dependencies there? Project name, project department. It's different than this department. Project name, project department, total. No, I don't think there is. So we'll assume not. And is there any dependencies between these non-key attributes? So let's see. Name, no, phone. Does phone determine first name and last name? Are these your J? Is there any sharing? I bet there's no sharing. How about IT? Oh, this guy doesn't have a key. Doesn't have a phone. No, there could be lots of people who don't have a phone. So I was wondering if the phone could determine the first name and the last name. Does the email address determine? There we go. The email. Everyone's got an email address, and so the email everyone's got a unique email address. There's no sharing. So the email can determine the first name and the last name. And these don't have anything to do with the key. Although it looks like this could be a candidate key then. Okay, anyway, so we'll get to that. So this is in second normal form, but it's not third normal form because the first name and the last name can be determined by the email address. In fact, you know, the EID can be determined by the email address too. So we have a case here where that would disqualify it from being in Bcnf, but we aren't even in third normal form. So anyway, so I guess we could split. Okay, so we would split this down further. Let me see. All right, so that explains second and third. The third normal form. Third normal form means there are no functional dependencies between non-key attributes. So let's convert this. We would have EID determines yeah. Yeah, I don't know how. I guess it doesn't matter, but we can have this. We really should have something like this. We should have this in one. This be, and we'll put this over here. This in one, and then in another we have this without this. All right. So this is one. table, and this is the other table. So we have, this is in third normal form because we don't have any dependencies between, we don't have any dependencies among the non-key fields. And it's in Bcnf because all of the dependencies, all functional dependencies are implied by the keys. Okay, so we could in fact have done this. Let's say the let's say we decided to put this field over here, and we take this up. Okay, this is in Bcnf because all the dependencies are implied by the key. There's no, it's in third normal because there's no non-key dependence depending on each other. It's in Bcnf because in fact, all the functional dependencies are implied by the key itself. This, however, it's in third normal form because there is no, let's see, the phone number, I guess you can say the phone number is determined by the, I guess you can say the phone number is determined by the email address. Yeah, I guess you'd have to split that out. I guess you really do have to put this over here. I was trying to formulate a case where you would have the email address. Oh wait, all the functional dependencies are applied by the keys. This is determined by this. Okay, I guess I'm trying to come up with something on the fly here. So now these are all in Bcnf because it turns out, just in the case of if something is in first normal form and you want to determine if it's in second normal form, but the key is not a composite key, then you know that there can't be any non-key attributes dependent on the partial key, because you can't make a partial key. So you know that if something is in first normal form and it's a single key, then it's automatically in second normal form. Same with third normal form and Bcnf. If something is in third normal form and it only has a single key, a single attribute as the key, in other words, it doesn't have a composite key, then you know it's automatically in Bcnf. So this, right? Okay. All right. So let's now we can still have problems even though we're able to reduce something all the way down to Bcnf. Okay. With Bcnf, all functional dependencies are implied by the keys. So let's say you have an example like this. Okay. Let's say you run a pizza shop, and I think I threw out this example before. Let's say you have a pizza shop, and you have a special where customers can get up to 3 toppings and only one of each type. So 1 type of cheese, 1 type of meat, and 1 type of vegetable. Okay, so you decide to make a so then the orders start coming in, So topics can be of one type. So when the orders start coming in, they're stored in a table like this. Let me, they're stored in a table like this. Okay, so your first order comes in, pizza order number 1, and you gotta so you decide you're gonna have the key be pizza and type, because you know you can only have one type of each, and so this is so you need both. So for pizza 1, you have this one cheese, 1 meat, 1 vegetable. You know, there's no duplicates. For pizza type, pizza number 2, you got meat, cheese, and vegetable. No duplicates. It fits. However, if you look closely, so this is in Bcnf. All the it's in. Is it in Bcnf? No, it's not in Bcnf, because all of the functional dependencies are not implied by the keys. All the functional dependencies are not implied by the keys, because we have because cheese is determined, the type is determined by the topping. So we have a dependency where topping determines type. Okay, so what does the rel var keep an anomaly of pizza? What does the rel var keep an anomaly of a pizza containing? Oh no, how? Let me read here. How does the rel var keep an anomaly of a pizza containing more than one topping? How does it keep that from occurring? Well, it keeps it from occurring because you can't put in, you know, if you already have a 2 meat, you can't put in another 2 meat, you know, because there's already one, and the primary key is pizza and meat and type. So that's how it keeps the anomaly of having more than one type from occurring. And then we ask what anomaly is shown occurring. Well, the anomaly that's showing is that here we define mozzarella as a cheese, and here we define mozzarella as a meat, which is not right. Same with sausage and cheese. So how do we restructure the rel var into smaller rel vars to keep that anomaly from occurring? And the way we do it, of course, is we have a pizza type topping, but we also have a okay, so we have a let me go to sheet 5. We have a pizza type topping, and we also have to have a topping type. So I'm going to do this. Topping, put this here, type, put that here, and we want to get rid of, so we'd leave that in there, we'd leave that in there, we'd leave that in there, we'd probably have to get rid of this. Oh, so topping is the primary key. Topping is the primary key. In this case, pizza and type are the primary key. Okay, so you could have one table like this and one table like this, but you still have this problem. So you could, I guess, you could take this off, and what happens if you do that? Oh, wait a minute, I should fix this first. You could change this to sausage, and that's to cheese, I guess. So let's change, okay, well, anyway. So you have this, and then you still want to have this because need to keep it. You need to be able to keep that anomaly of happening where you put like two cheeses on the same pizza. So you want to have this. Well, these two other things are the primary key. You want to have this, and maybe you can fix this. Take this out. See, we don't have sausage, so let's put this down here and get rid of this. So meat, vegetable, yeah, okay, so we can take this off now. Okay, so that's fixed. So we have that, but we still, okay, so if we have this and we have this and if we have this and this, we lose what the actual toppings are for each pizza, right? I mean, this tells us the types. This tells us what the types, what toppings are the types. But we still need something that tells us pizza 1 has mozzarella on pizza. So in other words, we still need this, and we get rid of this. Okay, so we actually need all three of these, and we need to we would need to join them back up, and natural join would work. We join them all back up, and then we know then we have our original table, and we're protected by we're protected from these anomalies. When we add in a new pizza with topping, we need to be able to add. We need to be able to certainly add it into this table. Oh, this has got to be both. Both of these are. No, actually, if it's like this, then it supports. No, topping can only be at one time. So yeah, I guess we don't need to do that. What happened? Oh. No, obviously we need both, because if it's just this, then we already have a 1, so this obviously needs to be both. So, oops, I took it off. So we've got this, and this. So it's these three tables, and we need to join it back up again to actually get. We join them all back up again to get the order. When we put when we add a topping for a pizza, we need to be able to add it into every one of them, except for this one. But we need to be able to add it into here, and we need to be able to add it into here. If we cannot add it into either one of them, or if one of them we cannot add it into, then it violates one of the integrity constraints. So anyway, that's so if we actually go back to this thing, so all multi-value dependencies are implied by the keys. We'll get to the multi-value dependency example later on, but there aren't any in this example. There weren't any in this example. Fifth normal form means that all join dependencies are implied by the keys, and so these are there's a join dependency here where they have to be in fifth normal form. So these are in fifth. These three tables are in fifth normal form because so they're in third, right? There's only two. They're in fourth. I mean they're in Bcnf, There's no multi-value dependencies. We'll learn what they are in a moment. So they're in fourth normal form. And are they in fifth normal form? And the answer is yes, because there's join dependencies and they're implied by the keys. So if you naturally join the whole thing together, you'll get the original valid table back with the pizzas and the ingredients and they're being properly typed. So you see why you need this, and you see why you need this, and you see why you need this. All right, so it turns out that this is okay because the two mistakes canceled out each other. If it wasn't okay, then we would end up seeing, then this would be wrong. There would either be two meats or two cheeses. Okay, so that's one example, kind of interesting example. Okay, so here's another example. It's a similar kind of example. This last example is a good example, which describes multi-value dependencies. But let's go over this one first. So I've shown you this example before, and I don't think I have any quizzes based on this yet in this class. But here we have this rel var that stores the, and let's say there's campus voting, or there's some sort of way that we know that this database is being kept, and it's the best cuisine per campus, the place that's got the best cuisine for the campus, that's closest to the campus. And so you have campus and cuisine, and there can only be one best burger place for UHM. There can only be one best pizza place. There can only be one best Afghan place, and so on. So we have something like this, and so it makes sense that the primary key would be this plus this, because that way you will never have more than one favorite type of a cuisine at a campus. But the problem, of course, comes in that the place determines the cuisine. So it's very similar to this other example here. The place determines the cuisine. So of course the rel var that can take place is you can accidentally put in Kentucky Fried Chicken as a burger place or something. Or you accidentally put in you accidentally put in Burger King Manoa as a chicken place, or as a Chinese place or something. The structure of this table will not let you will not protect against that. So and it's not in Bcnf because we've got this functional relationship where the place determines the cuisine. And that's not implied by the keys. These are the keys, and it doesn't. So in this functional dependency, it's like this non-key determines a partial key. So it's not in Bcnf. So it's a case where it's in 3NF, but it's not in Bcnf, and it's because we've got this partial key thing here. So the way we would fix it, we have the same kind of issues here as in the last one, and so the way you'd fix it is the same kind of thing. Let's copy it over, copy kind of here, and so we would just make 3 of them. This we make, see, 1, 2, 3, and here we get rid of this. Now let's get rid of this, and let's get rid of this, and let's get rid of we need cuisine place. Now we got that campus cuisine. We need campus place. Campus place. Yeah. In this one, both of these are the key. In this one, this is the key. And in this one, both of these have to be the key. So let's put this over here just so we can have the key on the left. Uh-oh. What did I just do? Cut. Insert cut cells. Okay. So we end up with, what happened? Oh. So we have this table. Yeah, we have this table. We have this table, and we only need one Afghan. Love is Afghan. Does that place still exist? Ooh. Let me just clear it. And this obviously we need all these. So, and to get the original table back, you got to join them all back up again. If you only have, you know, two, you know, if you don't have this one, you get that, you can make the mistake of that anomaly. You can join it back up and you get something, but you can have the cause this anomaly, and then place does not participate in the key. In that case, I'm just talking about this one here. So, so these are all now in fifth. Okay. So let's see an example of fourth. No, let's see an example of a multi-value dependency. So how about this table here? Let's say we have this table. Now forget about what multi-value dependencies you may know based on this, but you know, you have and it's over at KCC. Okay, you got these ICS321 classes, and there you got 3 instructors, and you got for ICS 101 you have these 2 textbooks. I think there's something like this, and there's actually more instructors in it too. But so this is information that you may want to have and keep, but you can't really break this. This is in fourth normal. This is in Bcnf. This is like what they call an all key relation. You can't just have course and instructor because there's going to be, you know, the course plus instructor cannot be just the primary key. Instructor plus textbook cannot be just the primary key. You know, course and textbook can't be the primary key. You need all 3 of them there at once. So this is in Bcnf. There's no relationship between any of these. It's not like this. Well, there is these dependencies, but you can't use the functional dependencies to reduce this table. The multi-value dependency here is that course actually determines instructor, and course also determines textbook. Okay, but there's no real relationship between instructor and textbook, and we can have instructors other places, and we can have textbooks other places, and so you have a multi-valued dependency, so it's not in fourth normal form. So the way to the way to get it into fourth normal form is you got to get rid of this multi-valued dependency. It's in one table. We've got course determining this, and we've got course determining this. So you got to split it out into separate tables, and you end up with let's put that here. You end up with, see, these are all a key to begin with. So you want to split these out. So you want to make this V1, and you want to make this and this V1. And so that's fine. When we can reduce this down. And we can reduce this down. Let's see, is that all we need to do? So we join that up. Yeah, that's right. And then to get back to the original table, we do a natural join. How is that? This is the second edition, second part, and that was in. Oh yeah, it's got that. No, I guess we need. Why do we need instructor textbook? You know. Oh. Let's try to find that example. Oh, it's right here. No. It's right here. CNO, XNO. Oh, I guess that's all we need for this one. Yeah, it is. Right. Yeah, this is because it's two. Multi-value dependency. Yeah, so this is an example of where you only need to divide it into two. Wait a minute. You'd end up with so if we actually put this into a database, and we go, let's go and see what do we have anything in here I can use? Here. Yeah, I'll use this one. So I'm going to put in I'm going to start a new table in here. A new table called, no, I'm going to, instructor, course instructor and course textbook. Course instructor, and it's going to just have two columns. And the columns are going to be course, and it's going to be varchar 20, and it's going to be instructor varchar 20, and they're both going to participate in the primary key. Oops, yes. Okay, and then I'm going to have another, and then I'm done. oh, it's going to be in INNODB, and I'm going to kind of run it. Run. Yeah, run. All right, that's course instructor, and then I'm also going to make course textbook. So I'm going to create another new table, course textbook, and that's also going to have 2 columns. Go course varchar 20, textbook varchar 20, and it's going to be part of the primary key. And it's going to be INNODB, save. And for this one, I'm going to insert ICS321 technology in action, whatever the name of that textbook is, ICS321 Microsoft Office 2017 or something like that. I don't know how far it is, where we are on that. Go. All right, and that's that table. And this table, I'm going to need to insert ICS321 Singer, ICS321 Ellis, and ICS321 comments. All right, so now we've got this, and we've got this, and the structure. That's the key. Okay, so I'm going to see what happens when I do select from natural join course instructor. And I get this, which is exactly what you're supposed to get. All right. Yeah, it seems to me the examples of something not being in fourth normal form have to do with they end up only being having to join. They're join dependent, but just 2 tables. And these examples, these other examples. So actually, next time I present this, if there's a next time, then I think I'm going to present this one first, because this is a good example of something's in Bcnf, but it's not in fourth because there's joint dependencies, and it's pretty clear what they are. And then so you fix that by breaking it down into tables that are in fourth normal form. They are in fourth normal form. There's only 2. There's this. Yeah, you need right. You need both of these as the key. They're both the key. They both participate in the key, but and yeah. All right. So and then in these examples, they are in fourth naturally. No, they're not in fourth. These are not in fourth. But you can actually join. You can join this with this, and you get back this. right? You join this with this. Oh, no, because it's not going to match up the pizza, the mozzarella, the cheese. Well, it'll match something up. It's just that these won't be in order. You have to have that to it's a joint dependency among three tables, and that's the same as this example too. But anyway, in the real world, well, okay, so in the real world, you wouldn't, you know, once you understand functional dependencies, then something like this, where we're talking about a multi-value dependency, and they're join dependent, you aren't going to probably be thinking about it in those academic terms, but you'll look at this and you'll know that there's something wrong. And if when asked, you say, well, can you break it down by can just two of these be the you break it down so just two of these is the primary key? No, they all have to be the primary key. Okay, so we have that, but we know that we can break it down because it's obvious what's going on here, and especially you may know that the course determines the textbook and the course determines the instructor, but they don't determine. But instructor and textbook don't really have any relationship with each other than the fact that they're both part of the same course. And so you would just know to divide this into two tables and have the information separately, because right off you could see what type of anomaly could take place. You might leave one of these out, and there's no anomaly. It's missing, but you would find out. I mean, the anomaly is ICS321 in these two cases had two textbooks, but in this case only has one textbook. I mean, that's the anomaly. It's not consistent. But there's nothing about this table that can help you learn that. Nothing about the structure of this single table in Bcnf that can help you with that. But if you split them up, but you see it's not in fourth normal form. So to put it in fourth normal form, you split it up, and then you join the table back up again. You join them back up again to get the table of all the valid tuples for this, and that's how you have your answer. And so you'll be able to figure that out without looking at it going, oh, geez, this table is in Bcnf, but it's not in fourth normal form. You probably won't be thinking that. You'll be thinking, wait a minute, this if we just did this, it would screw up, no doubt. This because it depends on the secretary entering this in. Secretary who's got a zillion other things to do too, and missing something like that would be pretty easy to do. Plus, if the instructors themselves are giving the instructions and the instructor leaves one out, who knows? Anyway, so that's all I kind of had for today. This is kind of the final lecture on normal forms, but it's important. So we still have like one more day on this, and I'll figure out what I'm going to do next Monday. But we can start getting into some of the newer stuff here, where we're going to actually write SQL for all of these relational operators, which might be kind of fun, and then doing transactions and so on. So, all right, any questions? Okay, see you Monday.